Glaze defects. Glaze defects are any flaws in the surface quality of a ceramic glaze, its physical structure or its interaction with the body. Body/glaze interaction problems. Glaze defects can be as a result of the incompatibility of the body and the selected glaze. Examples including crazing and peeling. CRAZING. Crazing is a spider web pattern of cracks penetrating the glaze. It is caused by tensile stresses greater than the glaze is able to withstand. Common reasons for such stresses are a mismatch between the thermal expansions of glaze and body, from moisture expansion of the body, and in the case of glazed tiles fixed to wall, movement of the wall or of the bonding material used to fix the tile to the wall. The cracks can allow the ingress of water into the cracks. Once fired, wire tends to be more resistant to crazing due to better development of the glaze/body interfacial layer, which reduces stress gradients between the glaze and body. In pottery, a distinction is often made between crazing as an accidental defect and crackle, which is when the same phenomenon, often strongly accentuated, is produced deliberately. The Chinese in particular enjoyed the random effects of crackle, though it spans the spectrum, in Ru where it is a tolerated feature of most pieces, but not sought, while in Guan where a strong crackle is a desired effect. The causes of crazing include thermal expansion mismatch. Poor fit between the glaze and the body's thermal expansion is the main cause of crazing and can be due to firing too quickly. Moisture expansion of the body. Porous bodies swell slightly due to absorption of moisture. Where glazes own only slight compression, this can be sufficient to bring them into tension. The problem results in delayed or secondary crazing, which occurs over a period of time after the ware has been produced. Glazing too thickly. This is a common cause of crazing. Glazes, which should be craze resistant, can craze if applied too thickly. This is because the further the glaze surface is away from the body, the lower the compression acting on it. Thermal shock. Opening the kiln too soon above 100 degrees C can cause crazing and dunting. Above 200 degrees C, catastrophic failure can occur due to the volume changes at the cristobalite inversion around 225 degrees C glaze fit. The matching of the thermal expansion of a glaze to that of the body on which it is held. To prevent crazing, the glaze must be in compression when the ware has been cooled from the kiln to room temperature. To achieve this, the thermal expansion of the glaze must be less than that of the body. Stegger's crazing test is a method for the assessment of the glaze fit. It is undertaken by measuring any deformation on cooling of a thin bar that was glazed only on one side. A common method of testing glazed ceramic ware for crazing resistance is to expose pieces of ware to the steam in an autoclave at a minimum of 50 psi. Stegger's rules are a series of empirical rules put forward by the H.R. Stegger for the prevention of crazing and peeling. To prevent crazing, the body should be adjusted as follows: decrease the clay, increase the free silica, replace some of the bull clay by kaolin, decrease the feldspar, grind the silica more finely, biscuit fire at high temperature. Alternatively, the glaze can be adjusted: increase silica and slash or decrease fluxes, replace some CO2 by B2O, replace fluxes of high equivalent weight by fluxes of lower equivalent weight. To prevent peeling, the body or glaze should be adjusted in the reverse direction. Peeling. The breaking away of glaze from ceramic ware in consequence of too high a compression in the glaze layer. This is caused by the glaze being of such a composition that its expansion coefficient is too low to match that of the body. It is the opposite of crazing, as are the preventative steps. See Stegger's rule above. Peeling is also known as shivering. Metal release. Regulations have existed since the late 1960s to protect consumers from the potential risk of toxic materials, mainly metals, being released from glazes into drink and foodstuffs. Lead and cadmium are the metals of greatest concern, although testing can be extended to include others. The propensity for any glaze to release metal may depend on complex interactions between the formulation used, any applied decoration, and the kiln atmosphere. Monitoring the level of metal release from glazed ware forms part of the quality control procedures of all reputable producers. Test methods are specified according to national and international standards, although testing usually involves the ware being immersed or filled with a 4% acetic acid solution, covered and left for 24 hours at room temperature. Although if cooking ware is being tested, high temperatures are needed, the acetic acid solution decanted from the ware and the concentration of leached metal measured by atomic absorption spectroscopy. Acceptance limits are enforced by legislation and whilst varying between countries all are within the ppm range. Some of the most well-recognized legislation are, across Europe, EC Directive 84/500/EC 1984 for the UK GB Ceramicware Safety Regulations C1647 1988, and for the United States of America FDA Compliance Policy Guide 7117.6 and 7117.7 for cadmium and lead. Blisters. A large bubble sometimes present as a fault in ceramicware. Blisters appear as large bubbles either just below or penetrating the surface, leaving sharp, rough edges that collect dirt. The surface of the glaze is very unpleasant and looks like a boiled mass of bubbles, craters and pinholes. Crawling. A defect that appears as irregular, bare patches of fired body showing through the glaze where it has failed to adhere to or wet the body on firing. The cause is a weak bond between glaze and body. This may result from greasy patches or dust on the surface of the biscuitware or from shrinkage of the applied glaze slip during drying. The fault is more likely to occur with once fired ware such as sanitary ware. Metal marking. Metal marks are dark lines, often accompanied by damage in the glaze caused by the deposition of metal during the use of metal utensils. The cutlery, or other relatively soft metal, will leave a very thin smear of metal on potterware if the glaze is minutely pitted. The glaze may have this defective surface as it leaves the glossed kiln, or it may subsequently develop such a surface as a result of inadequate chemical durability. The fault is also known as cutlery marking. Pinhole. A fault that is commonly the result of a bubble in the glaze when it was molten that burst but was only partially healed. The bubbles are most often from gas that originates from air trapped between the particles of powdered glaze as the glaze begins to mature, or from gases evolved from carbonate compounds. A specific example of pinholes is spit out. These are pinholes or craters sometimes occurring in glazed non-vitreous ceramics while they are in the decorating kiln. The cause of this defect is the evolution of water vapor adsorbed by the porous body during the period between the glossed firing and the decorating firing via minute cracks in the glaze.